So, if y'all have learned one thing about me, it's that I am flexible and go with the flow of whatever my co-teachers tell me to do. And next Friday, whether you guys know this yet or not, is going to be Science Fair Immersion Day for human testing. So we are not going to have a typical math class. But what that means is we're going to start your test on Thursday and finish it after break. So, yeah. So whatever you can't do on Thursday, you've got all of winter break to practice and do homework and review what you need to. But tomorrow, the homeworks that are due, also up here, 424 and 431. So if those homeworks are nowhere close to done, get on. So act like this was a pop quiz. If you right now got asked to find the area and perimeter of those two tile arrangements at the top of your paper, because you're not doing your homework right now, we're doing our classwork. Sorry, not two, 3 tile arrangements. I was thinking of an 87, there's only 2 of them, but that's because it gets trickier. So, we're going to use some random cards to see who can help me out. And again, this is a 2-day lesson, 2-day homework. That's why your homework seems a bit bigger. It's for 2 days. All right, we shuffled yesterday, so I think we should be nice and shuffled up. Donna, you get the lucky thing. You get to start wherever you want to start. So do you want to start bottom left, bottom right, top left? You tell me where we're going to start taking our walk. Well, right, but which part of A? Where do you want to start our walk? You want to start down here, up there. We're going to walk around the shape for perimeter. Ooh, actually, I guess I should ask you, do you want to do perimeter or do you want to do area? Up to you since you're first card. All right, Donna calls area. So Donna, what is our area in part A? And actually, I think I've got this. I've got this bigger over here. Wait, what? X squared, and how many of those?
1.
Just 1. Now, we don't have to put the 1, but it'd be a good idea. Keep going.
2x
Plus 2x plus 2. Does anyone have questions on how we found that area? I'm going to let this ride for today, but you guys got to be on your best behavior. Okay? Because you know you're not supposed to be sitting together. Perimeter here.
Wait, I don't understand.
What don't you understand? Was that Emery or
What?
Bethany? I don't know.
Nothing. Why can't I just put 4x? Oh, I was thinking perimeter. I'm sorry.
Because they are not the same tiles. But yeah, you're thinking perimeter. So for perimeter, Sam, where do you want to start? Bottom left, top right, bottom right.
Bottom.
Bottom, which side?
Bottom right.
Right? All right. Do you want to go up or do you want to go left?
Left.
All right, Sam wants to go this way.
So that's x plus, that's x plus 2.
Yeah, because that's a 1, that's an x, and that's a 1. So Sam says the bottom here is x plus 2, and I would label that on your paper. Sophia.
Isn't that middle one x squared?
The shape inside, the space in here is x squared. But if you go back and reference this, that Sam got my copy because Sam was in Hawaii.
Why
Jealous. This reminds us that the edges of x squared are only x long, right? You can use this as your reference page. But thank you for asking, right? Because that's stuff we need to clarify. Sophie, since Sam took us this way, I think now we're going to walk up the left side here. Aside from my line's not quite straight. How long is that? Yeah, x plus 1. Then safe, if I do boom, ba-doom, how long is that?
Both of them are 1, but that equals 2.
Yeah, so 1 and 1, so that's 2, and we might as well just say, all right, this is also 2.
What's the other one?
And what's this space between them?
X.
That's an x. And then I'm going to use the same color because I feel like it's the same. How long is this over here? Another x plus 1. So if I go to collect the entire perimeter, Sophia, how many x's, do we have? Wait.
4, my bad.
Yeah, don't forget about this guy, although I wrote it on the white instead of out in the other space. So 4x plus, Bethany, how many constant do we have?
4.
Ooh, more than that. Remember, the constant is all the numbers. The plus 1, plus 2, plus 2.
7. 8.
4x plus 8. Any questions on how we got that? When you and your teammate think you're done with B and C, check with another team. See if your area and perimeter agree with them. And guys, we need things clearly labeled, like A equals, P equals, area versus perimeter. I'm going to give you a few minutes. I would start with area because it's easier. Oh, by the way, we got a no-name paper over here that is 4.2.1. So if you think you turned in 4.2.1 and it's missing, it's probably right there.
Sophie. So cute.
It kind of looks like boy handwriting, but I mean, could be yours. Lane, I have your 4.2.1 in my hand, literally about to hand back to you, so that's not yours. Do these feel easier or more difficult than what we were doing yesterday? Easier because we don't have to do any what? No subtraction, right? Alright, so you might live to regret those words.
Hey, you said that yesterday.
I did not say subtraction's easier.
No, you said that. I was like I lived to regret it.
Guys, you might.
Yeah.
Might.
I mean, till now, I'm still alive.
And see, we're going to die to live to regret. Alright. Arfon, you get lucky. Do you want to start with area or perimeter?
Area.
Why area?
I don't know.
Because it's easier. Guys, for
Both
real,
easy.
area is just look at it and name it based off what you see. Perimeter, we got a lot more work we got to do. So what is our area here?
X squared.
And I'm going to be specific and put 1x squared. You don't have to. I think it's better.
Plus 2x.
Plus 2x.
Plus 2.
Wait.
It's just the same.
1x squared plus 2x plus 2. 1x squared plus 2x plus... Does that mean the perimeter's the same? Oh, because it's arranged differently.
You gotta be goofy if you think
Emery,
they're just these areas.
where do you want to start for your walk?
I will start on the side that's like this.
The right side?
Yeah.
Okay, you want to start bottom or top?
I'll start at the top.
Top. You want to go left or down?
Down.
How long is this?
Well, the first chunk is X, and the second chunk is 1.
So if you need to label this on your paper, this is why I put these on your paper. Put little labels inside if you want. And then Emery says, okay, together that's X plus 1. So I'm also just going to make it a little darker because I wrote it in that color. So then it's up to you how you deal with the other pieces and how you break things up. My opinion, not right or wrong, is that I would like to group this whole bottom together. So I'm separately going to look at this. How long is this, anybody? 2, right? Because it's a 1 and a 1. So then, Ashley, how long's the bottom? Yeah, because we got a 1 and a 1 and an X. So X plus 2. And then, how long is this, anybody? 2. Oh, and then I think this side, we already know because we know this side. So X plus 1, And then how long is the top? I don't really want to write in red.
X.
X. Guys, this is the trap door. People forgetting that the edge of x squared is only x long. It is x squared because they took a length of x and made a square out of it. They said, all right, x wide, x tall, square now. Say, well, the area was that we have the same tiles.
Wait, not the area. I meant the perimeter. I mean, what you guys are going with? Well, I think it's still the same.
You think it's still the same? It could be. It might just work out, right? But does it look the same as the one before? No, it doesn't look the same. But it might end up having the same distance around. So let's total this up. Come on, how many x's? Sorry, man. How many x's? Okay, so we got 4x again. Devin, not here today. Devin, we miss you. Lane, how many constant?
Hold on, let me check. I just gotta double check. I think it's 6. Wait, but like, hold up. Yo, wait, come on. Listen, here's what I'm thinking, right?
Yep. Thinking. Yep.
Right, so, under the x squared box thingy, right? There's a 1, but it's not for the x squared.
Well, like here?
Yo, wait, never mind.
We have that over here with this plus 1.
No, that's not me. It's 8. Never mind.
So 1, 2, 3, 4, 5, 6, 7, 8.
It's the same thing as the last one. You
You
said the perimeter wouldn't be the same, but it is.
It didn't look like it was going to be the same. It looked different.
all the perimeters
It's
are the same.
No.
No. So, do not, Emery did that on purpose, do not assume if they have the same area, they will have the same perimeter. That is not true. This, coincidentally, does. Same area, same perimeter. Great. That will not always happen. That will not always happen, guys. So let's try this one. This one feels probably a bit more manageable.
Wait.
At least compared to what we did yesterday. I'm only going to give you guys like 60 seconds. I think most of you are already done with this.
No, I think the perimeter's the same.
What the area is. Oh, no.
Ooh, who said it? Come on, say it louder. This area is different.
I agree with that.
The area is the same as the
So,
perimeter.
Jack, what is our area here?
The area is 3 plus 2x.
Yeah, I'm going to start with the x's just because like we like putting variable. Okay, really the not rule, but the habit is put your constants last. Lane, put it away. Put your constants last in the expression. Aside from that, like x's, y's, we normally go in alphabetical order. So you put like x's, then you put y's, then you put z's, or you put a's and then b's, and then c. But there's no like rule about it. So could Jack have said 3 plus 2x? Yeah, it's the same. And then let's just do class answers for this, because I feel like we can probably do this pretty easily. From here all the way over to here, what length is that?
2x plus 3.
So 2x.
Now wait, what length is this?
2x plus 3.
So wait, couldn't I just say we have 2x plus 3 twice?
Oh my
And
gosh.
that'll get us
4x times
4x
Plus 8. 6.
Plus 8.
plus 6, and then here, and what? So the
Goes right.
perimeter's the same. 4x plus 8. What the heck?
I told you it was gonna be the same, and you said no.
I did not say
You said nothing,
no.
actually.
You said all of the perimeters are going to be the same. And like, look at the next two on the bottom of the paper.
Oh well, not all like.
You
the
said
kids.
all.
I meant in this problem.
You said all.
As in the problem.
Don't come at me, Emery.
Come at you. Oh my gosh, I can't snap.
You can't snap.
No, I
All
can
right,
snap.
so
in my
like
hair.
we talked about yesterday, we don't know what x is until someone tells us. Hey guys, x is 6. Go back and recalculate those shapes now that we know that x is 6.
Really?
No,
Yeah,
what?
like really.
What if we don't have
Man, where could
Graph
room
paper.
happen?
Graph paper, no, graph.
Like almost unlimited. Like almost like I have feet of it up here. I think if I stack all the graph paper I have, it might be as tall as me.
You should do that. I should make that cardboard thing.
I'm a little crafty. Post-its and tape. But I mean, it falls apart if you don't take care of it. Okay, so X is 6. Guys, I'm going to actually clone all these pages. And then relabel things.
I didn't want to do it with graph paper, but now I know I'm going to have to.
If X is 6 for each of them. Okay, we still got a couple weeks.
But officially,
We're in December now.
exactly.
Graph paper. Graph paper.
In my opinion,
How
it's
lovely
not
are your blue lines. Graph paper. Graph.
Ooh!
Ah,
Great point brought up by Matt. If I just want to come over to the expression and say, well, I knew what the area was, I knew what the perimeter was, right, kind of, we sort of knew it. X squared. Okay, X is 6, but what the heck is squaring? Well, if my square is 6 by 6, how much space is inside of it? Well, what is 6 times 6? So guys, this square, if it is 6 by 6 now, it is 36. That's not, we can't see that. So my x squared is 36. And now my x tiles, if those are 6 by 1, right, there's a 1 here. What is 6 by 1? 6, but I have 2 of those. So 2 times 6, that's going to give me 12 more. And then still 2 is just 2. So what's our area here? Ooh. So our area is 50 units squared, because we don't know what units we're working in, but we would say 50 units squared. Because it's area, we would just say units squared. You look like you have a question. Ashley, you look like you have a question. Do you have a question? Are you sure? Our faces say a lot, guys. So perimeter, that's easier. Guys, if x is 6 for perimeter, and what you could put on your paper is literally, we can just plug in x is 6.
4 times 6.
What is 4 times 6?
24.
24 plus 8. So our perimeter, 32 units. Ooh, maybe that's what you were making a face at. This is u squared for units squared, because we're talking about space inside, as opposed to our perimeter is just units, because it's just the length around the outside. Make that happen for B and C if you have not yet. If x is 6,
Should I do perimeter though, right?
if x is 6. So, like on here, if we make x is 6's instead, now I don't know where your work is to reflect what we just did up there, so it might be tough for you to look back at this when you're doing your homework. I don't see the number 6 anywhere on your paper. And also, I've been encouraging you guys to do it on graph paper because there's not very much space on here. The choices that you're making are the choices you have to live with. If you choose to not write down what I write down, it feels silly to me.
Wait, is the perimeter and the area the same?
No.
Well, they're definitely not the same units. So even if you get the same number, they are not the same.
So we said the perimeter was 32 units.
Today I'm like extra tired.
Sorry, like you want to? Well, I'm trying to get through the deck of cards as much as I can every day. Brayden also.
Really? Yeah. He wasn't in band.
Eli. We still have x squared here, and we said the x squared when x is 6 is how much?
Ow.
What is 6 times 6? Yeah, guys. Look up here, and if you're not writing this down, that feels silly. Sophia, Ashley, we good? And if we have a question, like, let's talk about it.
We were talking about math.
I figured, but like, is there something we're confused about, or what?
Can you go back?
Yeah, to the one before. So what over here had you confused? So the 36 came from this square that is 6 by 6. Are you cool with where the 36 came from? The 12 came from this being 6 by 1, and therefore that yellow part is 6. This is 6. And then we have 2. So the 12 came from 6 on the left side, 6 on the right side. That makes sense now? Thank you for asking. I could tell something was rocky. And not Rocky like Adrian. No, you guys get the joke.
What?
So, Rocky's a movie series about a boxer. Yeah.
That's
So, x squared over here, x squared, if x is 6, what's 6 by 6?
12.
36. Careful, we're multiplying, not adding. 6 by 6. This square, 6 by 6. So then, I'm going to use the same colors we did on the last slide. What is an x tiles area now? That's 6. And so is this.
Wait.
So 6 and another 6, and I'm actually going to write these out because Ashley made me realize that I should show my work. And then plus, guys, are these tiles ever going to change when x changes? No, these don't care about x. These 1 tiles do not care what x is. They're 1. Period. That's it. All day long, they're 1.
Period.
So plus those 2. Oh yeah, we're going to get the same thing we got on the last one because it's the same area, right? We said it's the same area. Now our perimeter, you could draw it. You could replace your x's with 6. Or you could come over here and do 4 times 6 plus 8. What's 4 times 6? 24 plus 8? 32. Wait.
It's going too fast.
Wait. So
Okay.
why? Wait.
Exactly
Why do
what I
we
need to
find
do.
out the perimeter if we all know it's just 32 units again? If all the other ones were just 4x
Okay, well,
squared.
if we recognized, hey, this is the same as A, I guess you're right. We could have just said, hey, we know it's the same as A. But C is different
It's not bad.
for the area.
Actually, for the area. What was that?
It was an elephant jumping into a pool.
An
It would be.
I don't remember the lyrics. We used to sing that in
Ringing through the skunk.
Through the sky.
Oh.
The holiday song with Do You Hear What I Hear? And do you see what I see? And do you, I forget what else. And, yeah. I hope not. All right, am I good to move on?
Yes.
Okay. You gotta speak up if you are not ready. So, we don't have x squared anymore. Oh no! But we do have our x's and guys. I'm gonna like walk around and label all this. So this would have like now turned into 1, 6, 1, 6, 1, right? For perimeter. I'm talking perimeter because perimeter's tougher. Or just fill it in. Guys, we wrote this for our perimeter. All right, 4x plus 8. I don't have to do all the work. I can come over here and just say, okay, what's 4 times 6? Oh, it's the same thing again. Because you guys said perimeter is the same, but area is not. Oh, wait. Can I just fill in x is 6 up here? Yeah. So what is 2 times 6?
12.
And what is 12 plus 3?
15.
So our area is 15 units squared.
This is like sort of like this, like this.
Well, it went from we don't know to 6, right? Like however big. Now what if what if x went from 6 down to 1/2?
Oh my days.
Oh my god, I guessed it.
So if, well, because it's on your paper. Good guessing.
What?
So if x is now 1/2, for those, let's go back and recap. No, wait. I want you guys to draw, forget about calculating for a second. Draw a picture of what A would look like if x is 1/2.
Oh god.
What? Wait, what about the...
Seriously?
How do you split in half?
Bro.
So,
Oh, just...
so,
There's still half 6.
no, now x is not 6. Now we're going to switch this. We're going to say x is 1/2, but we're going to draw a new picture of this. So check it.
Because it's getting messy. Wait, so 6.
All right, so imagine this, but now x is 1/2. So check it. My 1 would still be 1, right? I'm going to label my 1 tile 1. But what will the size of my x tile be now? Sophia? Half by what? X is 1/2. What can't change?
The square. I don't know.
The 1 does not change. This 1 does not care about x. That 1, this 1, those are not going to change.
No, one thing is gonna change about
So
this.
the 1 is still 1, but x is now only 1/2 tall. What about the x squared? How big is that going to be now, Sage?
Half square.
It's 1/2 by 1/2. 1/2 by 1/2.
Wouldn't that be 1?
No. That would be if you add 1/2 and 1/2, but 1/2 by 1/2 is really small.
Wait, why is the green one so small?
Because x is 1/2 now. We shrunk it way to... X is smaller than 1 now. My x tile got shrunk down to itty bitty.
Why is it smaller than 1?
Because it's 1/2. 1/2 is smaller than 1.
Sure.
So this is only 1/2. Guys, if you want to label this, we made our x's 1/2s. The bottom still has to be 1. This tile is 1/2 by 1/2. So yeah, its size would actually be 1/4. These are still 1s, right? Like this is a 1, this is a 1. But this right here is 1/2 now. Because this is super funky. And not like in the good way.
Funky.
So because we don't know what x is until somebody tells us, this is why it gets so weird. If x is something small, visually speaking, this looks way different than what we started with.
Definitely.
Like, way different. It does kind of look sad now.
It's like a castle or a face.
Now I kind of want to play castles tonight.
What's castle? Castle.
A game we play at our game night. So let's skip over B.
It's like castle.
Thank you.
Yes, please. What time?
Oh, but you
Let's do C. Let's draw out what C would look like.
Let me figure out
So
the
on your graph paper, let's draw out what the new C would look like if x is 1/2. Do the 1 tiles change?
No.
No. I should see pencils in people's hands.
What I would do?
So the 1 tile does not change. The x tile is now going to be 1/2 by how tall? Because this can't change, right? This 1 does not change, but x is now 1/2. Save, what are you doing with the calculator? What are you doing? Because I don't know that any of this needs a calculator. You're right. You're off task. You're bad. But what's better than an apology is a change in behavior. The 1 tile is still the 1 tile. My x is now. So wait, x can be smaller than the 1 tile? Now wait, could x be the same as the 1 tile? What would make the x tile be the same as the 1 tile? If x is 1. Just like you guys, you can be anything.
Oh my gosh!
But X is 1/2. So
We should code that.
What do you mean? Say more.
How does it work if the X is 1/2?
What do you mean, how does it work? What are you talking about, how does it work? I don't know what you're asking. No, keep pushing. What are you asking?
I don't know what I'm saying.
Like, when x is whatever someone tells us x is, it just, now we know how big it is. So when x was 6, we can say, alright, x is 6 and the 1 tiles are only 1. But now that x is 1/2, it's smaller than the 1 tiles.
Couldn't you just add the 2 X's together and make a whole?
Means, yeah, if I move some things around, 2 of those x's put together would make a whole. You're right. Other questions? This is weird as we start doing it. Alright, last 4 minutes, because we're going to pick this up tomorrow. At the bottom of your paper, 87. I need you guys to forget about area because it feels easier. Find the perimeter of each of these shapes.
What's that?
The perimeter. Like, we don't know what x is.
Okay.
We're back to not knowing what x is. We're back to not knowing x. What's the perimeter here?
Why? Oh, can I do area too?
Yeah, I mean, area doesn't take long.
Alright, let's just. Oh. Okay, we're done.
Just make a star of that. X minus.
I would draw arrows or color code or something to help your brain out.
This is confusing.
What am I doing? Let's copy these down here bigger.
Which we have no clue what that is. Wait, Mr. Hudson. If there's 2 blocking out on that X side and there's 2 adding, would it just be X?
I'd still write it all out. Like, you're right, the +2 and the -2 can cancel, but I would still write it out. Why would I go over it? Did you do the -2? But did you do it when you gathered up all your like terms? Because I see 1, 2, 3, 4, 5, 6, 7, 8. But you wrote down 8. What about this -2? Oh, sorry, I was missing this -2. So we need to put this together. You're right, it needs to become 6. We need to put the -2 with the 8, and these together to equal 6. Yeah, so it's just x plus 6. Eli already went. Jane, the right side. They cautioned us about this, right? If we read what it said, it said be careful about the right sides. What I've drawn in, like the bright green up here, those lengths together, how long is that? It looks like it, right? But we don't know. We can't actually trust what things look like, and we don't know what x is. Now, if x was 4, I'd agree with you, but we don't know what x is. You want to phone a friend? Donna, you want to help out?
It would be X minus 2.
Since the whole length would be x, and then we take away 1, take away another 1, what is left is x minus 2.
Would it work if you
Yeah, x plus negative 2 would be fine. Now wait a minute though. Here, how much is boom, boom, boom? 3. How much is boom, boom, boom? Another 3.
Top and bottom.
Ooh, and the top is 1. Always 1, right? And the bottom is 1. And the left side, and that is where we're going to stop for today. Please clip this somewhere safe. Think about the homeworks that are due tomorrow. Yeah, have a great day.
Yeah, okay.
I don't have anything else to say. I thought there was another announcement, but nope. I don't know.
Have a great day, Mr. Hudson.
You too. Hold on, let me pause this.